Okay, so we are now in our part 2 for our examples. Okay, so we have this example here. For example 1, determine all the important elements of the curve x squared plus 6x plus 12y minus 3 is equal to 0. So what is the area bounded by the curve in its Lattice Rectum? Then you have to sketch the graph. Okay, so sketching the graph is really important, guys. So this is one of the techniques, and this is really my advice for you to really know on how to know the elements of the conic sections, okay, circles, parabola, ellipse, and hyperbola. So you have to know how to sketch it. Okay, so we'll try to solve this. Okay, so this is the equation that is given, the general equation, guys. Then what we will do is we will convert this into the standard equation of the parabola. In order to do that, so we have to complete the square, or the completing the square process. Okay, so how to do that? So you make it x squared plus 6x is equal to negative 12y, then plus 3. Okay, so this value of 6 here will be divided with 3. Okay, so I 2 rather. Okay, so this will be equal to 3. Okay, so your equation now will become, okay, so x squared plus 6x, then this 3 here should be squared. Okay, so 3 squared, which is equal to 9, which will be added here. Okay, so plus 9. Okay, so that is the process of completing the square. Okay, so this value of squared here, 6 divided to 3, then this 3 will be squared, equal to 9. Then add it here on the first term, or the left side equation, then equal to negative 12y, then plus 3, then also add on the 9 here, okay, for both the left and the right equation. Okay, so factor out this equation. Okay, so factoring that out, so I think that is equal to x plus 3 squared. Okay, so try to do FOIL method, okay, for us to check if this factored equation here is the same with this. Okay, and this is equal to negative 12y plus 12. Okay, then factor out, so therefore we have x plus 3 squared is equal to negative 12, then y minus 1. Okay, so this is the standard equation of the parabola that we have get from completing the square. Okay, so from our previous discussion, so I think that equation is, I think this is the equation, guys. Okay, so x minus h squared is equal to negative 4p, then y minus k. Okay, so that is the same with x minus h squared minus 4p, then y minus k. Okay, so with this equation here, then we can already assume that the parabola is concave downward. Okay, concave downward. So from this equation, so we could get the value of h. Okay, the value of h here is negative 3. Then the value of k here is positive 1. Okay, so take note, this is negative h, this is positive 3. So therefore that is negative 3. Okay, we substitute it here. Then for k, this is negative 1, so negative k, so therefore your k is positive 1. Okay, so therefore this will be your vertex. Okay, that will be your vertex. So vertex is negative 3, negative 3, 1. Okay, so we have this first element here. Then next. Then also we have this 4p here. Okay, so 4p is equal to, so we have this here, 12. Okay, so p is equal to 3. Or also this is our lattice rectum. Okay, so take note of that. So our lattice rectum is 12. Okay, so here we go. So we have this vertex, we have this lattice rectum here. Then the value of p is 3. Okay, in some books, guys, p is denoted as a. Okay, in some books, so you might get confused, but it is the same. Okay, p and a is the same. P and 3. So next, we'll determine the focus. Okay, so focus is, so if we grab this one, three, 7, 8, 9. 5, 6. Okay, so this will be our origin. So now, so our vertex is in negative 3. So in here, negative 3, 1. So this will be our vertex. Okay. Vertex is negative 3, 1. Okay, so the value of p is 3. So meaning, p can be used to determine the directrix and the focus. Okay, so take note that p value, so from the vertex to the focus, so that is distance p. The same with directrix, from the vertex to the directrix, so that is distance p as well. Okay, so if we denote it here, so from this vertex, so we will go into count p, which is 3. Okay, so 1, 2, 3. So this will be your directrix. So take note, we have already assumed that our parabola is concave downward. Okay, so this will be our directrix. Okay, so but also you should also put the equation of this directrix. So this is a line that is directly in the positive 4 value, and this is in y-axis, so therefore this is y is equal to 4. So this is the equation of your directrix. Okay, so this is the p distance here, p distance, which is equal to 3. Okay, so vertex to directrix. The next is our focus. So our focus is within the concavity of the curve. So you have this vertex here, then 3, 1, then 2, then 3. Okay, so this will be our focus. Okay, so the point of our focus is in negative 3. Okay, so negative 3, then 1, 2, negative 2. Okay, so I'll put this here. So focus is negative 3, negative 2. Okay, this will be our focus. Then lastly, in order for us to graph the parabola properly, so we'll be using the lattice rectum, which is equal to 12. So if we have this graph, okay, so this is the focus, then our lattice rectum. Okay, so lattice rectum, so if that is equal to 12, then half of that is from focus to the right is 6, then distance from focus to the left is 6. Okay, so what we'll do is count 6, okay, to the right and count 6 to the left. Okay, so focus -3, then 1. Okay, so 1, then we have this 2, then 3, 4, 5, then 6. Okay, so this is R, okay, to the right. So with this point, so you have 3, positive 3, negative, negative 2. Okay, so to the left, count 6 as well. So you have 1, 2, 3, 4, 5, then 6. Okay, so this is the left part. Okay, so that is negative 9, negative 9, negative 2. Okay, so the graph now will look like this. Okay, so intersect, then also, okay, say that is our parabola, then lattice rectum is this portion. Okay, so lattice rectum, so you may also put a distance here. Okay, so lattice rectum is equal to 12. Okay, so these are the important points. Okay, take note guys, from focus to the vertex that is also distance p. Okay, so these are the important elements for a parabola. Then also try to solve the area bounded. Okay, area bounded by this. Okay, by your parabola. Okay, by your parabola and lattice rectum. So we have AP is equal to LR squared over 6. Okay, so LR is 12 squared over 6. So this is equal to 24 square units. Okay, so this is the area bounded by the parabola and the lattice rectum. Okay, so try to sketch this again, okay, for you to analyze it correctly. Okay, so stay tuned for the next examples.